Hello, Keith Rucker here at VintageMachinery.org. Guys, the project of the day is I've got to make a tool to use here in the shop. And what I've got is I've got a project I need to do pretty soon that's going to require doing some milling of some wedges that have a very specific taper to them. And the taper I need is it's a 1 inch per foot taper on them. And to do that, I'm going to do it over on my milling machine, but I need something to help set that angle up precisely every time. And to do that, I'm just going to make a taper gauge. So what I've got here is a piece of A2 tool steel. This is in its annealed state where it is machinable, and I am going to machine this out, rough machine it. This is going to be my first step. Then we're going to take it to the heat treat oven. We're going to do a heat treat on it, harden it, and then I will take it to the surface grinder, and I will actually grind that final precise angle on there where we'll have that exact taper to use. Now, most of my taper gauges, let me show you an example of a taper gauge. So here are some, these are actually angle gauges and not taper gauges, but you kind of get the idea. This is a set that I've got, 1 degree, 2 degree, 3, 4, 5, 10, 15, and 30. Between these, you can make up a lot of different angles. And you see you just have a piece of hardened steel there with a particular angle on there. There's a 1 degree, there's a 30 degree. And these are some custom made ones that I got in a toolbox. JHD made these. That's a 15 degree angle. I like that one. It goes down to a stop. But there's a 1 degree one, a real wide one. There's a 4 degree one that he made. So anyway, you kind of get the idea. Now, the difference between what I'm going to be doing and what these are is that this is going to be a taper. And my taper is, again, it's 1 inch per foot. Now, in degrees, I did the math. That comes out to 4.764 degrees. So obviously, these angle gauges really are not going to be helpful to me if I want to get that precise angle. I really can't add that up because it's a percentage of a degree. So we're just going to make a custom one. Again, I've got this piece of stock. This is 3/8 inch thick, 1 1/4 wide. And I want it to basically go from that 1 1/4 down. And I'm going to make mine 6 inches long just because of the part that I'm making, I want it to be longer than a typical angle gauge here. I'm basically making this specifically for the job that I've got, but it can be used for other jobs down the road if I ever need that 1 inch per foot taper again. So enough talking. Let's get in here and get to work, and let's get one of these things made. I'll take this out of the package. They wrap this thing up in some paper to protect it, also to keep it from rusting. I'm not going to use the entire length, so I'm going to try to save this sleeve to put my remainder back in to store it in. So I'm trying to get it out without tearing that sleeve up. All right, let's see if we can get that to come on out. It's got a wax type seal on the inside of it, so I'm going to have to open it up, I'm afraid. We'll wrap it back up in it, tape it back up. Tell you what I might do. Tell you what, I'm just going to cut it in this wrapper. How about that? And that way I can at least leave the end still wrapped up. So I need a 6 inch piece. If you can't beat it, just cheat it. Let me go get my saw and we'll just saw that thing off and we'll just cut that wrapper with it. Just take my little DeWalt portable band saw. There we go. And I'm just going to take a piece of this paper that I cut off of there. We'll wrap that around that end. And that should protect that, keep it from rusting. And we'll put that up, have it for a project down the road. All right, I want to lay this thing out now to just kind of rough out that angle and that taper, and I'm just roughing it. This is not a finished angle, but it's going to get me close enough so I don't have to grind a gazillion bit amount off of this thing when we get it to the surface grinder. So what we got here is 6 inches, roughly, just measure with the scale. So you can see there. So this taper is a 1 inch per foot. For 6 inches, that's half a foot, so it'll be half an inch. So I'm just going to put a mark down here at half an inch, and we will just, I'm going to need a longer scale. So I'm just going to rough me a line across there. And that's the material I need to remove, and I want to leave the line showing so I have some extra to grind. So what I'm going to do is go over to the milling machine, get this thing set up, and we'll mill that off. And like I said, this is nothing precision at this point in time. I'm just removing the bulk of the metal. Set up over on the milling machine now. I just basically got this set in there with that line just above the vise jaw, and again, we're not going to cut all the way down there to it. We're just roughing this out. I've got a carbide end mill in here. See if we can get some more speed here. Yes, carbide tipped end mill, carbide insert end mill. Hopefully this will help cut that tool steel. And we'll just start working our way down. That end mill's got a little bit of run out in it. It looks like one tooth looks like it's doing most of the work, but it's cutting. I'm roughing, so I'm not too worried about it. That end mill is just a cheap import that I bought a long time ago. Chinese made. I need to probably invest in a better one. I'm going to go back to this other side so I can kind of touch off just shy of down there on the bottom of that. I'm just going to raise it up until it starts cutting about right there, and then cut them across, and that'll leave me some material to have to grind off. Just raise it up just a couple of thou and come back across it. Barely skim it. All right, I think we're got it milled. I'm going to go just hit that on the grinder, clean that edge up. Before I go to heat treat, I want to mark this with what taper it is, so I'll know what it is later on. So I just got some stamps here, and we'll just go ahead and stamp it in there. Let's see, we'll go about right there. 1. 1 inch. F 1 inch per foot. There we go. That way I'll know what it is. Let's get our heat treat oven set up and we'll do a heat treat on this. All right, so next step, we need to get this ready for heat treat. And to do that, I want to wrap it up in some stainless steel foil. What this does is it basically, in that heat treat process, it will help keep any oxidation from happening, or limiting the amount of oxidation that happens on this thing. It just seals it up, protects it from the air, and that will really help from the standpoint of getting that scale and stuff all over this while it's going through the heat treat. So I'm just going to cut me off a piece of foil here. Again, this is stainless steel foil. It's made for heat treat purposes like this. This is not aluminum foil. If you use aluminum foil, it will melt. Another little trick when doing heat treat is wrap up a little piece of paper in there with it. What that will do is that it will actually, any oxygen that's trapped inside of this foil, that will burn this paper, and it'll just turn this paper to ash, but that will basically consume any oxygen that's trapped inside of this. So what I'm going to do is we're just going to fold this over. I want to get this as tight as I can get it on there. So I'm just going to fold this over. We're going to fold it over again. There we go. And we'll fold these ends up. Heat treat oven I'm going to be using is my HotShot 360. This is a heat treat oven that was designed and built by Stan Zinkowski over at Barzy Industrial, and you can go check out his YouTube channel for more information on this this oven and how to operate it. I'm really not going to go into a lot of detail on that here on this video, but what I am doing is I'm just taking it in there. I got a little block of metal in there, and I just kind of prop this up so that it's sitting up. I don't want to lay it down the insulation. That'll cool one side of it. I want it to heat evenly around it. So it's just laid up in there where the air can get all the way around it. We're going to close it up. I'll turn it on, and the unit that I've got has a programmable controller in here. The top line is the temperature inside the oven. The bottom line is, I think, what it's set on. It's actually running a program right now. I'm going to come in here, program yes, program run yes, and you see it's on run. So I'm going to shut the door, turn on my heat, and what's going on here is the top number is the actual temperature inside the oven. The bottom number is what it's shooting for. I've got a program in here. It started at 100 degrees, and for A2, what I want to do is I want to heat it up slowly to about 1400 degrees and then let it soak. And when I say soak, just kind of sit there and pull that temperature in, and then I want to heat it up from there to 1800 degrees, let it soak again, and then after it's completely soaked through, I pull it out and we quench it. And in the case with A2, it's air quenched, so we will just put it out in the air and let it cool down. That is the game plan. It's running the program right now. It is slowly ramping up to 1400 degrees. I've got it over an hour to ramp up to 1400 degrees. Then it's going to hold it at 1400 degrees, I think, for 20 minutes. and then again ramp it up to 1800 degrees for an hour, over an hour, and then hold it there for about 30 minutes. And then I got an alarm set on here that'll go off to let me know, okay, I'm done. That's when we'll pull it out and do the quench, the air quench. To program this oven, you can go in here and manually do it, and I'm not going to show you how to do it. If you want to see it, go to Stan Zinkowski's YouTube page. Barzy Industrial is his YouTube channel. He has tutorials on how to do this. You can program it on the controller itself, or you can do it like I did. You can just pull this little piece out, take it in. It's got a USB port on it. You plug it into your computer, and it's got this great little computer, a software package that you can run on a PC, and you can actually put your ramps and your times and all that stuff, program it into the controller, and then just go put this back into the little HotShot 360 unit, and you're ready to go. It's really, really slick, works great. And but again, if you want to find out how to do that, go check out Barzy Industrial. If you're interested in an oven like this, Stan actually makes these himself. He sells them, and he should have that information over on his website, Barzy Industrial. So we're going to let this thing run its program, and it's going to be probably about 2.5 hours before we're ready to pull it out. We've been at it now for probably about an hour and a half. We ramped up to 1400 degrees, let it soak for a little while, and now we're on our climb up to 1800 degrees. And you can see over here, the green number is the number that we're targeting for. So that is programmed to slowly ramp up. Basically, we're going from 1400 degrees to 1800 degrees, so a 400 degree increase over 60 minutes. So you'll see this number on the bottom is slowly climbing up. Just a degree at a time. The number on the top is the red number. That's the actual temperature inside the oven based on a thermocouple that's in there that's measuring the temperature. And it keeps it within a couple of degrees. It's actually pretty darn close. Whenever you see this little out come on, that means that it's actually putting electricity to the coils in here to heat it up, and then it's just going in and out, in and out, in and out. We'll take a peek inside real quick. I'll open the door. You can watch that temperature drop real quick when I do, but just kind of get an idea of what's going on in there. All right, we're going to let her keep going. 1800 degrees, hold it for about 30 minutes, and then we'll do the air quench. We were slowly creeping up and getting close to our 1800 degree target. We're at 1794. Of course, that is slowly ramping up. We were going from, 1400 degrees to 1800 degrees in an hour. So basically increasing in temperature 100 degrees every 15 minutes. And that's the reason it's just slowly climbing up there. So 1796 is where we're at. Our actual oven temperature will vary a little bit, but it stays pretty close to that. It's programmed to just cycle the heating coils inside on and off until we get there. Once we get to 1800 degrees, which we're there now, what we'll do is we're going to let that just sit there and soak at that temperature for, I think it's programmed for 30 minutes, I think is what I got it programmed. According to the book, you want it to soak, I think 20 minutes for every inch of thickness. We're only 3/8 inch thick there, so it won't take long to get that temperature all the way to the core of that piece of metal. But since we have been ramping it up, we want it to get a chance to actually get that temperature solid, soaked all the way through. So here in about 20 minutes, I should have an alarm going off, and that will be my cue that it's time to come over here and take this piece out. All right, we're waiting here on our 20-minute alarm. We should be coming up on it here just in a minute or two. And as soon as that goes off, we'll open up the door, pull it out, and start our air quench. Also at that time, I think I got it where it's ramping down rapidly to 300 degrees because that's the temperature that we need to do the temper in. So the final stage after we do the heat treat here, this hardening is going to make it very hard but also very brittle. We want to actually temper it back so that it's not as brittle. And to do that, we run it through another temperature but not nearly as hot. And I think according to the book, it's 300 degrees is where we need to go to, and hold it there for about an hour, and then let it just cool down, and we should be good. So anyway, waiting on our alarm. Should be any minute now. Well, I guess we didn't get an alarm. It's ramping down, so I thought I had an alarm set, but maybe I didn't get it programmed right. But you can see the temperature is dropping down, so we're there. I'm going to pull it on out. We're just going to grab our part and go over here to a tray to put it in for the air quench. All right, I put it over here in just a metal tray that's got holes through it, and I'm just turning a fan on, and we're going to let that fan blow on it, and that air moving across the part will cool it down. It's still a quench. It's not like putting it in water or oil like you would with a lot of types of quenches, but this is going to allow us to get where we need to be. This is what this metal is designed to do, is to cool down in the air. Some people use compressed air. I think that cools it a little bit too fast. Some people will just let it sit out in the open air. Anyway, I don't know that it really matters that much, but I read different documentation, and I watch different videos, and I see different things. It probably really just doesn't matter that much, to be honest with you. All right, we're going to let that cool down, probably take it a good 20-30 minutes to get cool, and then we'll do our temper. It's cooled down. Let's get it out of its little pouch here. All right, hardly any oxidation on it at all. See the ash from our piece of paper we put in there. Looks good. So we're going to take it over and put it back in the oven at 300 degrees and let it temper for about 30 minutes, hour or so, and we should be good to go. All right, we're back over at the oven. It's cooled down to 213 degrees. I've just got it manually set on 300 degrees. And I want my program, no, I don't want to do my program this time. I want to run it, so go to yes, enable my heat, and we should start seeing that temperature climb back on up to 300 degrees. And I'm not going to run it on a program this time. I'm just going to let it go up to 300 degrees, and we'll hold it there. I'll probably just come back down here to the shop in about an hour, and then we'll just turn the heat off, turn the whole unit off, probably just turn the heat off so the fan will still run, and let it cool down overnight, and it'll be done. All right, I've been holding this temperature now for about an hour at 300 degrees. And we're going to pull it out and just let it cool down naturally in the air. Just for fun here, I'm going to check this to see how hard it is. And to do that, I'm using my little PTC Instruments portable hardness steel testing set. This is a fairly simple model. It's accurate to about 1.5 points on the Rockwell C hardness scale. There are much more accurate units out there, but this gives me a good idea where we're at. Pretty straightforward. You want to start by having a nice smooth surface. It's nice to have a shiny surface. I'm going to kind of polish a little area there. I'm just taking a little bit of Scotch-Brite and knocking that oxidation off the surface. And what I'm going to do is, this is a little center punch. It's a self-punching center punch, so it's spring-loaded. You just take it on here. It is calibrated to make a punch of a certain strength, like that. This end is not sharp, it's not a point, it's kind of dulled over, but it makes an indentation into the metal. And then you take this little instrument here. There's a flashlight built into it that lights it, and what you do is you center this up over that little hole that you did, and you look down through this little telescope piece, and you can read a scale to see what the hardness is. And looking at this, looks like we're between 55 and 60 on the hardness scale. Let me double check that. Yeah, so I'm gonna call it 58. I'm estimating there. And to kind of give you an idea of what that looks like, I can't really show you down the viewfinder that I've got, but there's a picture in the instructions, and you just line this up. There's a scale in that little microscope thing. You put the line on the edge of that dot, you can see the indentation, and then you can read on the scale here what the hardness is based on how far that little punch penetrated down in there. So again, my punch is between about 55 and 60, so it's kind of in this range here, much smaller than what you see on the diagram. So anyway, that kind of gives me an idea of what the hardness is. That is fine, and I think we're through, at least with the rough milling and heat treat. We're going to be taking to the surface grinder. I'll probably be doing that in a separate video. Well, guys, that is going to be a wrap on this particular episode. Hope you enjoyed seeing a little bit of working with some tool steel, doing some rough machining in the annealed state, and then do a heat treatment and checking for hardness. But we're going to finish this gauge up in another video coming down the road over on the surface grinder. Then we'll be using this tool to actually make some tapered pins, or not really pins, but tapered keys that we'll be using in our steam stoker engine restoration. So that's going to be it, guys. As always, thanks for watching. Comments are appreciated. Leave a thumbs up if you like what you saw, and please do subscribe to the channel if you haven't already. And with that, guys, we'll catch you on the next video.